Channel sounding is the Bluetooth SIG's latest indoor positioning technology. At the moment, as of this filming, Silicon Labs is the only company which is able to supply ready-to-go equipment. In the following steps, I will show you what you need to avoid and what you need to be aware of when you want to get a working channel sounding demonstration based on Silicon Labs technology. To get started, obviously, you need two development boards. And what makes channel sounding a bit hairy is that in the case of Silicon Labs, you can only use a development board with a 40 MHz crystal. And this, there is a link in the show notes, is one which I found relatively affordable and very useful. And yes, I already unpacked it before, but this is the board, which you see is not particularly large. And to look at it in some detail, here we've got an USB-C port. This for the battery you can just ignore. And here on the top there are 3 buttons. This is the reset button, which we will need later. And other than that, yeah, it's a neat, tiny little board, and it just does its job, if you know what to be careful about. To start the development process, we need to visit this URL and we need to download Simplicity Studio for whatever version of the operating system we are going to use for development. During the first startup, which of course you don't see here because I'm using an aged installation, you will have a step-by-step process for downloading components. And one neat thing about Simplicity Studio is the auto detection. So you simply grab one of those development boards and you plug it into the workstation. And then, as you see here, it will run some kind of auto detection. Now we're going to ignore the update, and it will first discover here a Zegger J-Link, and then like this, and it will offer to download the software. And after that you can go here, you can click Start, and then you see here it discovers everything, and here in the field Secure Firmware, sometimes you need to do an update if it's out of date. And after that you go here into Example Projects and Demos, and then you look for the string CS. And then, as you see here, you get mostly here the Initiator and the Reflector project templates, which contain the actual Bluetooth channel sounding logic. And what is important here, we have one tile labeled Demo and one tile without the demo label. And why this is important, I will now show you in a separate little video. And this is a little memory map of what is actually happening inside of the EFR32 when you load it with one of the Silicon Labs provided examples. The user code is compiled to start at 0x8 blah blah blah. But the actual reset vector is at 0x0, as you can see here. And the code expects the presence, first of all, of a bootloader, which does some kind of OTA preparations and then jumps into the user code. And secondarily, it also expects the presence of a firmware. I wasn't able to find out where this firmware lives, but probably it's something related to the wireless stack. And this code usually is not accessible anyways for licensing and blah 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 reasons. And either way, what is very important, if there is no bootloader and you only deploy the user code, when the system starts, it has no way to get from the reset vector to the entry vector into your user code. And this, of course and obviously, leads to a non-working system. And while you can, in theory, deploy the bootloader from a finished project, the most comfortable way is that you just go here first and you click the run symbol. And while the board is connected, you see that it automatically deploys both the bootloader and the application and runs it. And after that, subsequent deployments of code usually, emphasis is on usually, leave the bootloader untouched. Be that as it may, next I'm going to show you here the creation process for the project skeleton. We go here, create, and then it starts this little template here. Basically, it behaves completely like cube. And we see it's now starting the project generator. And then we come up like so. You see here we've got an SLCP file. This is the actual project configuration. We've got a README and we've got some additional Bluetooth configuration files. But the code structure here is not relevant. It is more or less normal embedded code. What is relevant is how to run this and how to get the debug messages. For the first thing, for running, of course, we know that we have to create a debug configuration inside of Eclipse. And what you see here is there are two different configurations. Number one is a Silicon Labs ARM program, and number two is a GDB Sega J-Link debugging configuration. And I suggest that you should, if you have weird behavior, first start it as a Silicon Labs ARM program. This is officially a depreciated debugger, and the IDE will complain and moan and hiss. But this is the only way to check whether the aforementioned firmware matches the firmware which the SDK expects. And then for actual debugging, the correct configuration here is the GDB Sega J-Link debugging. So, here we go. Debug as, debug configurations, go here, create a new configuration. Aha, this is another interesting thing. You need to, or you should, compile the project once before you open the debug window for the first time. And then we can go here again, debug as, debug configurations. We delete the old configuration. We create ourselves a new one. And then we can select here one of the various. And what you see, it's important that you always select the AXF file, because that's the actual application. And then you can click debug. Go again. You have to wait a little bit because it runs another compile sometimes. And now you see something very, very important. It deploys only into the top part of the memory. And then, when it starts up, it halts here. If it does not halt at this breakpoint, always the bootloader is missing. And this is a very, very dangerous problem also, because if the bootloader is missing, Simplicity Studio does not show any warnings or anything, but the program simply doesn't run. And when we are done with the programming, we can use a local power supply, like here, just to plug it in. You see it blink, blink, blink. And to verify that it still works, I like to use a Bluetooth LE scanner on Android, because on iOS they are unreliable. So here we go. We've got our BLE scanner application. We scan and we see here CS reflect, and this tells us that the reflector is working perfectly. And now the next step is, when we click run here, we don't get any kind of interesting output here. I mean, we can always stop the program and see where it's diddling around, but we don't get any output, and especially no app logging output. And to get the app logging output, you need a separate terminal program. And I like to use Terraterm for this. And we go here, we search in the device manager for the J-Link, and we see here it is COM18. So then we go here, we connect to COM18, and then we have to go and we have to push the reset button. And after that, we see here a bit of a weird output. And to fix this, we go into Setup, Terminal, and we set the new line to Auto. And then when we push again the reset button, we are able to see the output. And we see here, this reflector is working perfectly. So now we can connect it to a power supply or a power bank and start erecting the initiator. And for erecting the initiator, we go back into the launcher perspective. We connect the board. We see first J-Link and then EFR32. Then we go here. We check again that the secure firmware is at the latest level. Example projects. We look again for CS. And this time first we have to run the initiator by clicking here, which I'm now not going to do. And after that, we have to create a project for the initiator, which is also by and large, as you know. So I'm also going to skip that here and instead grab my previously erected project and chase it over there. Again, we see the breakpoint. This makes us happy. And now we go into Terraterm. Yes, here we have a complaint from Sega. We love you too, Sega. The COM port has changed. In we go. And here we already see the various outputs for the ranging. And so with this, it is proven that the Bluetooth channel sounding based on Silicon Labs technology works perfectly. And with that, I am thankful for your attention. See you soon. Bye bye and all the best of luck.